Hello, and this is going to be part 2 of our difficult age word problem. Last video, we did this section up here, and it took about 10 minutes to go through that one, and we found, having gone through it, that we could reduce it to this equation here, and this equation is not, it's not simplified really. We'll simplify it later. Obviously there's there's t here, we could combine these kind of things, but we'll get to that later. But the focus of this session is going to be right here. We're going to take a look at this. And let's go ahead and move it up. And a bit of a warning here. So this is actually, it's the smallest line here, and it looks pretty easy, but unfortunately that can be deceiving. And a bit of a confession to make here is I actually got this wrong. I'm not going to lie to you. I actually got this part wrong. I had to go, and when I went through the whole problem, I went back and then I realized I got it wrong. And so I guess it's just one sentence, but it's actually a little bit tricky and easy to get confused. So easy actually that if you look this problem up on the internet, you'll see that Dr. Math had taken a stab at this part of the problem, and Dr. Math got it wrong. Yes, you heard me correct. Dr. Math himself got this part wrong. And really specifically, it was this part right here that threw him off, and it threw me off too. So I feel like I'm at least in good company since Dr. Math got it wrong. But we'll discuss what happened, what went wrong, and how to do this correctly. So let's first start this problem off from the top. Last time we started from the bottom. This time we're going to just start from the left. We're going to take a little bit of a different approach this time. We're going to start with this section up here. So let's do that. 10 years from now, Tim will be. So this is the first part of our what we can translate into an equation. So remember that Tim is our current age, right here, current age of Tim, and then say 10 years from now it's going to be t plus 10. So that this 10 years from now section is shown by this plus 10 right here. And then it says will be this will be section right here is going to be our equal sign. Will be. So moving on to our next part here, what is this going to be equal? He will be equal to twice as old as Jane was when. Okay, so the twice as old part, that's easy. We did this twice as old. We can just take this. That's just the 2 we're going to put out front here in our equation. 2. And Jane, of course, is Jane's current age is just given by this J right here. But this X corresponds to the time difference that we're going to add, because as old as Jane was when, it's not how old Jane was right now, that's just J, but how old Jane was when. So this was when part corresponds to this X, some time difference. So X is going to be our time difference, which could be positive or could be negative if it's after or before Jane's current age. So that's the first part of our equation. That's not too bad. We got that down. But what we have here is this X value, as old as Jane was when, that's our X value. And we got to use this next part here to determine what that X value is. What's the when? What's the when here? That's what we got to look at this next section for. Mary was 9 times as old as Tim. Okay, so this Mary, it's not just Mary's age though, it's Mary was. So that's where we're going to have this X, this time difference here, because we're as old as Jane was when Mary was. So it's the same X. It's the same. So we can start this off by having our M plus X on the left side. And on the right side, Mary was, so M plus X equals to 9 times, so 9 times is going to correspond to the 9 right here, as old as Tim. Okay, now here's where it gets tricky. As old as Tim. So confession here is when I initially read this, I just said, oh, as old as Tim. Well, Tim's just T. We're just going to have a T in there. The problem is when Mary was this different age, Tim was also a different age. So Tim's age is gonna depend on this time difference here. It's not saying as old as Tim's current age. It's saying as old as Tim. So as old as Tim was when Mary was 9 times his age. So we've actually got to add that x in here. So let me just give you sort of an example here. Let's say right now Mary is 19. So we say m equals 19. And let's say Tim equals, let's say 3. So if we wanted to find a certain time when Mary was 9 times as old as Tim, well, let's just say our x value is going to equal -1. That means a year before, so 1 year prior. So 1 year prior, we'd have m plus x would be equal to 18, because it's just 19 minus 1, and t plus x would be equal to 2, because it would be 3 minus 1. So in this case, you could see m plus x is equal to 9 times t plus x. So this, if Mary was 19 currently and Tim was 3 and x was -1, that x of -1 would satisfy this equality here, this condition. So we would find our x value for these starting ages of Mary and Tim. Okay, so this is the tricky part, and it's easy to miss this. But again, the real reason is because Tim's age is gonna change as time changes, right? He's not always going to be the same age. As Mary gets older, Tim's going to get older. So that's the tricky part here. But now we've got that, where we pretty much got everything translated into algebra, and now we can just work with these equations here. So we've got this algebra down, and now what we're going to want to do here is we weren't sure what this x was here. That's what we were trying to solve for. And so we can work with this equation here to solve for x. And then we can plug that, when we solve for x, we can plug it back into here, and we can get our final equation for this paragraph. Okay, and for our next step, we're just going to distribute this 9 here. So we're going to distribute that 9 to the t and distribute that 9 to the x. And we get m plus x equals 9t plus 9x. And from here, we're going to want to sort of isolate our x. So let's just go ahead and minus x on this side, minus x on this side, and since we're going to want to isolate x on the right side, we'll also minus 9t on this side and subtract 9t from this side too over here. So when we do that, we end up with sort of isolating x over on this side. 8x is equal to m minus 9t. And now if we take this whole thing and divide each side by 8, which we can do because we're doing the same thing to each side, then we can solve for x as this. So now that we've solved for x, we've determined what this value is up here that we weren't really sure about, right? Well, we haven't necessarily determined it, but we've got an equation for it. And this equation is right here. So what we do is we take this for x, we go ahead and plug that right in for x up here, and we end up with this equation. Of course, this isn't quite simplified because we've got the t over here and we got the t here, and so this time let's go ahead and do a little bit of algebra here to simplify this down to something a little more manageable. So let's see, first thing we want to do is we can kind of ignore these parenthesis signs because we're just doing an addition, so that we can just kind of take that out. So we'll have, that just becomes j minus 9/8 t plus 1/8 m, because we just kind of took that parentheses out. And next thing we're going to want to do, let's go ahead and distribute this 2 to each term here. Let's go ahead and push that through. So if we do that, we just multiply each by 2, and those 8's on the bottom become 4's. Alright, so moving on, let's go ahead and erase those. And the next thing we're going to want to do here is we have these 4's on the bottom, which are a little cumbersome to deal with, so let's just go ahead and multiply each side by 4. And from here you can see that we've still got a couple t's here, so we can get rid of those by, let's say, add 9t to each side, which I think we just subtracted 9t earlier, but let's add it this time. And we end up with 13t plus 40 equals 8j plus m. And that, ladies and gentlemen, is our final equation for this paragraph. Seems like an easy paragraph. It's pretty short, yet definitely tricky. So there it is. And just to kind of recap, we first video we took a look at this problem here, this first paragraph, and we found that it was equal to this. Second video we took a look at this paragraph and found that it was equal to this. And next video we will take a look at this last final and relatively involved paragraph. And the video after this we will move on to solve 3 equations. So that is going to be it for now, and I'll go ahead and link to the next video as soon as it's up. Until then, take care.